now we need to define a fixture. So obviously this structure will be fixed here and here. That's why let's go to Fixtures, then Fix Geometry, and here select this ball and this one. Fixed geometry means this joint here has 0 degree of freedom, which means it cannot translate in the X, Y, or Z, and it cannot rotate about any of them. It's totally fixed. Once you selected them and they are listed here, then hit OK. Now let's talk about loading this structure. First of all, we need to make sure that this structure can hold its own weight. That's why we need to define a gravity load. So right-click here and select Gravity. Before you hit OK, you need to make sure that the direction is correct. So since we have the top plane here on the floor, then the direction of the gravity will be perpendicular to this plane. And that's why it was very important to start our first sketch on this plane here, not on the top. Because if you start on the top, then this shape will be this way, and here you will need to define another direction for the gravity. So it's very important to pick the most proper plane to start with. Here, as you can see, we have the acceleration of the gravity value. If you have the vector in this direction, then hit OK. After that, I want every squared meter of the structure to hold 150 kilograms. So we have 6 meters in this direction, and we have 5 meters in this direction. So the total is 30 squared meters. Then I want 150 kilograms per squared meter, so it will be 150 multiplied by 30. So the total load will be 4,500 kilogram force. Now right-click here again and select Distributed Mass. Then you need to select the elements. You can select many different things here, like vertices or points. You can select joints, and you can select beams. In our case, beams will be the best solution. So select beams, then select this one, and all of them. And finally, the total mass, I want it to be 4,500 kilograms. And make sure you have the right unit here. If not, you can change between these, and you can have different units. I have 4,500 kilograms, then hit OK. Now, when you define a mass, it will follow the direction of the acceleration of the gravity, which means this load and the gravity goes in the same direction. We already defined the material from the beginning, and after defining the fixture and defining the load, we are ready to create the mesh. So right-click here and select Create Mesh. If your mesh is correct, now we are ready to run the analysis. So select Run this study. Here you have the results. The first thing is the stress. The maximum stress here is 8.8 multiplied by 10 to the power 7. And as you can see, the unit is Newton per squared meter. The yield strength is 2.5 multiplied by 10 to the power of 8. And here it's 8.8 to the power of 7. Which means this structure is safe, and we are still way below the yield point. But another important aspect to consider is the displacement. And that's why, double-click here. And here we have the displacement in millimeters. So we have 9.8 multiplied by 10 to the power of 1, which means we have 98 millimeters of displacement, which is relatively high.